Okay, now we're going to do section 1, topic 8, which is dealing with multiplying and dividing radicals and things with rational exponents. So if we look at the first one, it has 2 square root of 7 plus 27 all times the square root of 28 minus 3 times the square root of 3. So actually, I'm going to use our area model to multiply these. I just feel like it's going to make it a little bit easier. So we have 2 square root of 20, or 2 square root of 7, and then the square root of 27. And then we have the square root of 28, and then we have 3 times the square root of 3. So we look at this first one, 2 times 1 would just be 2, and then 28 times 7 is 196. And then 28 times 27 is going to be 756. And then 2 times the outside 3 would be 6. And then 3 times 7 would just be the square root of 21. And then 3 times 1 would just be 3. And then 27 times 3 would be 81. So there's all my pieces multiplied together. So then I want to see if I can simplify as much as I can here. So the square root of 196 is a perfect square. It's just 14, and 2 times 14 would be 28. I'm going to leave that 756 alone for just a second. The square root of 21 is not a perfect square, and you can't simplify it, so I'm going to say 6 times the square root of 21. And then 21. And then the square root of 81 is 9. 3 times 9 would be 27. So we can multiply these together. I apologize. This is minus here. Minus, minus, minus. So this should be a minus sign. And then this should be a minus sign. So 28 minus 27 is just 1. And then we have the square root of 756 plus 6 times the square root of 21. Now, I will tell you that these end up being the exact same thing. I know you wouldn't believe me, but 21 does go into 756. And it goes in there 36 times. And obviously, the square root of 36 does give me that 6. So these actually end up canceling out. And you're just left with that 1 there. I'm going to go ahead and do part B on number 1. What I'm going to do here first is simplify the things that I can. So the first thing I'm going to simplify is the square root of 12. That simplifies into 4 and 3. And of course, we want to take the square roots. So that's actually 2 times the square root of 3. We can also simplify the square root of 48, which simplifies into 16 times 3. And when we simplify that, it's going to be 4 times the square root of 3, but we already have that 2, so that's going to be 8 times the square root of 3, and then the denominator, we have 7 times the square root of 3. And I always like to cancel anything if we can. You'll notice that these both have square root of 3s, so we can get rid of those. 2 times 8 would be 16, and we still have that square root of 3 in the numerator, and then a 7 in the denominator. Okay, number 2, I'm just going to go ahead and rewrite one of these first. It's the same stuff we were doing in number 1. It's just we got to rewrite them as radicals. So I'm going to look at the second one. So 12 times the square root of 2 over the cube root of 27. And the cube root of 27 is a perfect cube. It's 3. So we have 12 times the square root of 2 over 3. And actually 12 divided by 3 simplifies to just 4 times the square root of 2. And that's as simple as we could get that one. Okay, the next one I want to look at is number 4. So we're trying to figure out what the z value is if we simplify both sides of these if we can. So let's first look at the right-hand side. So 2 square root of 8, I can actually simplify a little bit. So the square root of 8 is 4 times 2. And if we take the square root of that, we end up with 2 times the square root of 2. And if we multiply that together, that would simplify to 4 times the square root of 2 at the top, times square root of 49, which is a perfect square, so that would be 7, over 2 times the square root of 2. So what we're going to do here is divide out those square root of 2's. 4 times 7 is 28. and 28 divided by 2 would leave us with just 14 on the right-hand side. And then on the left-hand side, we have the square root of z. I'm going to rewrite them as radicals. And then we have the fourth root of 16. That is actually a perfect fourth root. The fourth root of 16 is 2. So we have the square root of z times 2 equals 14. So we're going to solve for z. So the first thing I'm going to do is divide both sides by 2. So we have the square root of z is equal to 7. So what number, when we take the square root, is equal to 7? Well, that is 49. So that would be the answer to number 4. The next one I want to look at is number 5. So we're proving that the square root of 8 times 2 is equal to 10 minus 3 times 4 to the 1/2. So let's simplify the left-hand side, and then we'll simplify the right-hand side. So remember, the square root of 8 simplifies to 4 times 2. So that would be 2 times the square root of 2 times the square root of 2. When we multiply those inside the radicals together, that would be 2 times the square root of 4. Well, the square root of 4 is a perfect square, and we want to multiply it by 2. So that left-hand side is equal to 4 when we multiply that 2 times 2. On the right-hand side, we have 4 to the 1/2. So we have 10 minus 3 times the square root of 4. Well, the square root of 4 we know is 2. So 10 minus 3 times 2 would be 10 minus 6, which is also equal to 4. Number 6 is talking about the area of a rectangle. It says, what is the area of a rectangle that measures 3 square root of 5 minus 4 square root of 12 by square root of 125? So here's my rectangle. One side is the square root of 125. The other side is 3 square root of 5 minus 4 square root of 12. So I'm going to go ahead and multiply this square root of 125 by both of those items. So 5 times 125 is 625 minus 4 times 12 times 125. Sorry, I'm checking. Is 1,500. Square root of 625 is actually a perfect square. It's 25, and 3 times 25 is 75. Minus 4 times, and 1,500, and I'll write it up here. The biggest perfect square that goes into that is 100 times 15. The square root of 100 is 10. 10 times 4 would be 40 times the square root of 15. And that's as simple as we could get that one. And then the last one is very similar. It's asking the area of a parallelogram. It tells me the area. So we know the area is 8 square root of 90. And we know one side is 2 square root of 5. So we want to divide to find that missing piece. 8 divided by 2 would be 4. And then we can actually divide that 90 divided by 5, which is in the radical, which is 18. And the only other thing we can do to make it more simple is to break up that 18 into 9 and 2. So that would give me 3. 3 times that 4 would be 12 times the square root of 2. And that is as far as we can get for the height. Again, please let me know if you have any more questions on section 1, topic 8 through reminder email. Bye, guys.